Hey, Nader, I think that we can start.
Okay, great. Give me just a couple of seconds. I'm going to go ahead and get everything set up. Okay, cool. So hello, everyone. And I hope you're ready to learn some new cool stuff. I think we're going to go ahead and kick this off. So with that being said, I guess I'll go ahead and share my screen. I think I'm going to make this a little smaller. Sorry, just trying to get the size of my screen sharing working good. All right, I think that's better. Cool. So yeah, this is going to be a workshop where we are building out a GraphQL API on top of a blockchain network. And the network that we're going to be building on top of is Ethereum. And this is probably going to be outside of the ballpark of most of the talks or the workshops given here. It's definitely a lot different than anything I had ever done when I started learning this stuff. But I think that it's becoming more and more relevant, I guess, with the emergence of a lot of the different jobs and opportunities that are out there. And it's kind of like maybe a new area just to explore, that to maybe accompany all of the existing knowledge that you have around GraphQL and how it might be used. So if you're interested in exploring opportunities in the blockchain space or the Web3 space, or even with a lot of the traditional companies like Stripe, PayPal, and Meta and all these companies adding blockchain stuff, this might become relevant to our everyday day-to-day jobs. Who knows? But with that being said, this is going to be broken up into two parts. I'm going to be giving a presentation, and then I'm also going to be doing a workshop. And the workshop I shared in the chat earlier, so you should see a link to that. It's a GitHub repo that we're going to be following, and this is it right here. Zoom in a little bit here. Cool. So my name is Nader Dabit. I'm a developer relations engineer at Edge and Node. Edge and Node is a blockchain startup that was created by the team behind the Graph protocol, which is what we're going to be talking about today. And we do a lot of different things. We do support this protocol from the perspective of us being software engineers that build out and maintain the infrastructure for this protocol. We also do Web3 tooling. We do Web3 open source. We're creating a couple of Web3 applications that are going to be open source. We also do Web3 awareness and venture capital. So one of the things that I do a lot is just teaching people how to build stuff and sharing reference architectures and stuff like that. So the Graph is what we're going to be using, and it's one of the many Web3 web infrastructure protocols that are out there. And it is an indexing protocol for querying blockchain networks like Ethereum and IPFS. So what does that actually mean? Well, when we think of traditional databases, they are created and are built to be made in an efficient manner for us to query and to save data to. So a traditional database like a SQL or NoSQL database, there are no constraints around decentralization. So we know this is going to be our data, so we can store and we can optimize for read and write operations. But in a blockchain, the nature of it is that we have this data that's being written over the course of time, days, weeks, months, and years, and it's being written in these blocks. So all of the innovation is typically happening around write transactions. So when you hear about a lot of the innovation that is happening, you often hear discussions around how many transactions per second does this protocol handle? How much does a transaction cost? How long does the transaction take to be processed? What is the block time and things like that? But what you don't hear often talked about is how to read all of this data. So what developers did in the past was that they would take these blockchain protocols, they would decide the data that they needed, and they would build out their own proprietary centralized indexing servers, where you kind of are going and you're gathering all this data, you're saving it in a database, and you're opening up your own API endpoint on top of that. The problem around this was that it was very resource and engineering intensive, and it also kind of broke the entire idea and the security principles around decentralization, because the blockchain data is supposed to be the source of truth. So how do you actually make this decentralized if you're centralizing it in a database to kind of read it? So the graph is an indexing protocol that allows developers to build these APIs that kind of read all this data, indexes it in a decentralized manner in a peer-to-peer network of nodes. And then developers, once they've deployed those, can open up their API endpoints for any other developer to build out front end or other applications on top of it. So to kind of explain that a little more, again, a traditional database might look something like this, where we kind of have a database, we have built an API endpoint on top of that, maybe a serverless function or some type of server. We're going to be sending a request to this API. It's going to then read the data. It's going to then process that maybe in a return, and then it's going to bring that response back to the client. But again, we can't really do this when we're reading data directly from the chain, because the chain is kind of thought of as the database. So we don't really have this compute layer in the blockchain space. So what are some other examples of indexers in real life? Well, Google or any search engine is an indexer. When we want to find information on the web, we can't just go and view all of the websites, because there's millions of websites that are out there. So how do we find the information that we need? Well, Google and other search engines have this idea of an indexing system where they crawl the entire internet, they find the relevant data, they store it in their own centralized databases, and then they open up an API endpoint on top of that, either via some actual API that we can interact with from an application, or in the case of Google, we just have like a website that we can visit. And when we enter a term into the website, it's going to their databases and it's kind of searching what we're looking for, and then it returns with the connection to the website that we would like to view. So Google is indexing and making it available for querying by us on the front end. Another example is a library. So when we go to a library, we don't walk around the entire library for hours looking for the book that we want. There's an indexing system where the Dewey Decimal System or something like that might tell us exactly where to look for a book. And then we can go directly and we can just find that book. So in a similar sense, these APIs called subgraphs sit in between the smart contract and the user interface and allow developers to query and have different types of data fetching that you might need for your typical application. So you have these different types of, I guess you could say, queries that you might hit your app with. And you need different types of selection sets from your database. So you might need full text search, or you might need relational data. You might need filtering, sorting, all of that type of stuff. So subgraphs kind of enable that. And once you've deployed your API, then it's deployed to a decentralized network of nodes, and applications can start querying for this data. without relying on a centralized service. Instead, they're going to be hitting this query market that's comprised of a decentralized network of indexers, and all of these indexers are kind of competing against each other to provide the best service at the best price. So when we think of how we pay for an API request from something like serverless function from AWS, it's similar to that. When you kind of call one of these endpoints, you're paying per query some fraction of a cent or something like that. Very similar to how you might pay for a Lambda API call. And the idea here is kind of like it is serverless. So how does the network operate? Well, instead of having a centralized service that's kind of like providing this utility for a profit, instead you kind of have a decentralized network of people that are all cooperating to kind of make this happen. And we have a couple of different participants. We have indexers, we have curators, we have delegators, and we have subgraph developers. And we are the subgraph developer today. So the indexer are kind of the people running the open source node, graph node software. So these are typically site reliability engineers, or I guess more likely DevOps people who can deploy one of these indexers, and they are going to be essentially allowing developers to deploy their APIs to the network, and then they are going to be processing those APIs. Subgraph developers are the developers that are building out the APIs, describing the data that they want to index. Curators are people that know which APIs might be something that would be useful, and then they can signal to use some of their GRT, which are the graph tokens, which are kind of like the utility token of the network. And they can say, oh, this API looks like it's good, so I'm going to curate on this API. And then as a curator, I can share from some of the query fees that subgraph gets. And then delegators act in the same way, except for indexers. So they can find an indexer that they think that is trustworthy, that they want to support, and they can delegate their tokens to that indexer. So therefore, and kind of instead of having a big corporation centralized kind of like maintaining this infrastructure and profiting off of it, you have people in the ecosystem and the community that are kind of doing the same thing, and they are the ones earning the rewards for running this decentralized network. And this is how a lot of the different protocols work. You have these different network participants that are kind of running the software infrastructure that we might typically have used in the past from a centralized place. So is the graph being, who is using the graph? The graph is serving over 1 billion queries per day at the moment. A lot of the Web3 DeFi ecosystem is using it. So projects like Uniswap, projects like Foundation, projects like Pull Together, all of these different projects I have listed here are using the graph, and it's kind of powering their UI. So we're going to be kind of building this subgraph for a NFT marketplace, because I think visualizing this token with pictures and images and art is pretty a nice way to kind of get started with it. But we're going to be walking through all of that step by step in our code base in just a moment, or in our tutorial in our workshop. But for now, I'll kind of walk through the steps of how that might look. So to get started, you would go to the graph.com, and then we have like a user interface where you can go ahead and define the name of the API or the subgraph that you would like to build. And then once you've defined this, you can then go down to your computer, onto your CLI, and use the open source graph CLI to initialize a new boilerplate subgraph locally. And this is almost like if you wanted to create a new React application, you might use npx create React app, or a Next.js app, you would do that. This just scaffolds out like a boilerplate for you to start writing some code. Once you have that locally, you would then define your data model, which is your GraphQL schema. You would define the smart contracts that you want to query from. And then you would also have some business logic that we're going to also write to define how that data is stored. So we have our data model, which is the GraphQL schema. We have the smart contracts we want to index. And then we have the other configurations that we're going to look at. So what does the GraphQL schema look like in the graph? Well, it looks just like any other GraphQL schema, with maybe one small difference, is that we have a couple of different directives that are native to the graph. One is the @entity directive, And this just means this is a data type that we want to be made queryable, and we want to save into the network. So a user is going to be something that we can query for by just adding this add entity directive. And then we also have the add derived from directive, which allows us to create relationships. So we want to be able to make a one-to-many relationship for users and tokens. And then we want to have a one-to-one relationship between a token and a user. And we have both of those declared here in this GraphQL schema. And then when we're ready to deploy, we just use the CLI to run graph deploy. And then we can test it out. In the user interface, we have an actual graphical editor and a GraphQL playground. And we can just start hitting the endpoint there. And then we're also given the ability, if we wanted to, at that point, deploy this to the decentralized network, because we kind of have this, we have a staging environment you could think of where we can just like test it out and even use it in our front end. And then we have the final step if you wanted to kind of publish to this to the network and allow other people to use it as well there. So you're just given a GraphQL endpoint, just like anything that you've probably used in the past, where you have the ability to kind of choose which GraphQL client you want to work with. So we will give you this, and then you define your query, you create your client, and you start interacting with it. So nothing different than anything that we've probably used in the past with GraphQL. Once you have that endpoint, you're ready to start going. So with that being said, we are going to go ahead and start working on the workshop. And the workshop is at github.com/dabit3, building a subgraph workshop. And I've also linked to it. And it looks like Lara has also linked to it again there as well. So this is where we're going to start from. And the NFT API we're going to build is for Foundation. And Foundation is a pretty cool marketplace for digital art. And you'll see that there's always some cool and sometimes weird stuff here. So this is what we're going to be querying for. And another cool thing about Foundation is that they have a developer portal. So if you go fnd.dev, I'll share both of these links here actually. fnd.dev is the Foundation developer portal. And here you kind of see if you're a developer and you wanted to build something on top of their smart contracts, they have a link to their contracts actually in their docs here. So these are their smart contracts. And this is one interesting thing about working with blockchain is in Web3 and stuff, is that pretty much if an application is deployed, you know, we're so used to thinking that a backend is proprietary and that we can't really use someone else's backend unless they explicitly create like a really nice API for us to use. Like maybe we might want to use the Twitter API, and it's very limited in the sense that we can't really do everything that Twitter can do. And then one day they might decide to just shut that API down as well, right? So it's not really something we can depend on to build a business on. But with smart contracts, these are completely open and public. So if someone builds an application and deploys it, then anyone in the world can build on top of that and know that it's going to be there a year from now and 5 years from now. So we're essentially kind of saying, oh, these people have built this smart contract. We want to use it, and we want to use it in this manner. You can also build out your own front end on top of this. So we're kind of taking their back end and we're using it. And you can do that with any blockchain application if you have their contract address, which is completely public and open and almost in all circumstances, I would say. They also have their own subgraphs. So you can kind of look here that they have their link to their main subgraph and then some query examples and stuff like that. So with that being said, just wanted to kind of show that, but we are going to build out our own API on top of that. So to get started, I'm just going to go here to getting started, and it's going to say open the graph hosted service. And I'm going to go ahead and sign in. Actually, I'm already signed in, so I might sign out. And then sign back in. All right, and what we want to do after we've signed in and created an account is go ahead and create a new subgraph. So here in the top right corner, we have this button for add a subgraph. So I'm going to go ahead and click that. And actually, I might see if I can't make this a little smaller. So people can see it better. Okay, cool. All right, so I'm going to click add a subgraph. And here we can give the subgraph a name and a subtitle. So I'm going to call this subgraph foundation subgraph or something like that. You can call it whatever you like. Looks like I already have one with that name on my own. So I'll call this foundation subgraph 2. That's because I've done this workshop before. And then I'll just call this like foundation subgraph. So we've put in just the name and the description, or the name and the subtitle, and we can go ahead and click create subgraph. I'm going to click hide just so it does not add it to the subgraph explorer, because I've created so many, but if it's up to you if you would like to hide that or not. All right, so once we've done that, we now have our boilerplate UI that we can now push to, essentially. So we can now go down to our CLI and start building out the subgraph locally. So to do that, I'm going to open up my command line, and I'm going to npm install the graph CLI. So I'm just going to copy and paste that. I already have this installed. Just going to go ahead and install it again though, just to kind of to show everyone that might be following along. Okay, cool. So once the graph CLI is installed, you should be able to just run graph. And then here you should have some output. And then if I do like graph help, you can kind of see some of the different commands you can run. And we're going to be starting off with init, and init is going to initialize a new subgraph. So not only that, but there are a couple of ways that you can run graph init. So for instance, I can just run graph init by itself. Don't follow along here. We're going to be kind of like doing a more in-depth command. But if we just do graph init, it will kind of like walk us through all these different questions. So like which protocol? Ethereum is like the Ethereum virtual machine. We might deploy to the hosted service or the Subgraph Studio. So the Subgraph Studio is for the decentralized network. We're going to be deploying to the hosted service because it's kind of like the sandbox that we can test things out with. We can give the subgraph a name, and it'll just like kind of ask us all these questions. We can also just go ahead and provide a lot of those questions up front. So that's what we're going to be doing with the command that we're going to be working with right here, where we say graph init, and then we pass in a couple of different flags. So the first thing we want to pass in is the from contract. So this is going to be the foundation smart contract address. So we say -- from contract, passing in the address. We want to pass in the network because there are dozens of networks that we support on Ethereum virtual machine. So we support Polygon, Avalanche, Celo, Arbitrum, Optimism, all these different networks. So we want to specify Ethereum mainnet. We also can pass in the contract name because a single smart contract might hold multiple contracts that are part of that single contract. So I believe this contract has not only the token, but other different contracts within it. So the one that we want to be working with is the token contract. And then we have this index events flag. And this is going to be brand new for sure to anyone that's not really familiar with how blockchain works or how Ethereum works. But let me kind of describe this so it makes a little more sense. And we're going to be diving into this a little bit more as well. And hopefully by the end of this, you'll have a good idea around what events are. So when we think of a GraphQL API, for example, a good example of like what this might relate to from what we're used to is that in a GraphQL API, we have this idea of a subscription, right? So we kind of go ahead and set up a GraphQL subscription. So when a mutation is made, we can subscribe to those events. And whenever someone creates a new item in our database, that event is fired. In Ethereum, there's something very similar to that. In your smart contract, you can create and emit events from within a contract whenever any action is taken. So if someone wants to say when a new token is created, we want to emit an event. And in that event, we want to pass in arguments similar to a GraphQL subscription where you kind of like have the mutation arguments. We can do that. So we essentially are going to say, okay, in this contract, we know there are events that are being emitted, and we want to go ahead and automatically say that we care about those events and we want to index those. And in doing this, we are going to go ahead and just be given some nice boilerplate code that will help us out down the road. And that's kind of like all I will say about it right now. But let's maybe take a quick look at the Foundation smart contracts real quick and maybe look at what these events look like. So if I go to Etherscan, which is how you can look at different contract code, and I go to the contract here, I'm going to go to the proxy, which is essentially this contract is speaking to another contract, but this is kind of the main contract. And I'm just going to kind of look for emit. We have an event that's happening right here where we have this ERC 721 contract, and we have this emit transfer. And then if we have an emit transfer, we probably have an event transfer. And the event transfer is us kind of like describing this event. And you define the event and then you emit the event. So like these are the events that we're working with. You know, another cool note is that with Etherscan, if you have the address, you can typically find the code for the smart contract, which is essentially kind of like the code base that you're working with. Okay, cool. So with that being said, let's go ahead and just copy all of this right here, and we're going to paste it here. So we have our graph CLI installed. We're going to say graph init from contract, network mainnet, contract name token, and index events. And here we'll choose Ethereum protocol, hosted service. And I believe I have all this stuff here. So hosted service, subgraph name. So this is going to be a combination of your username / the subgraph name that you defined earlier. So if I go to the dashboard here and I just copy the slug here, which is Dabit3 / foundation subgraph 2, then that should work. And then the directory should be the name of the subgraph. And then the network should automatically be set to mainnet. Contract address should also automatically be set. And then the contract name should also be set. So we should just be able to kind of like set the subgraph name, and then everything else should automatically be defined for us. And then from here, we just wait a couple of seconds. And what we should have now is a boilerplate that's been generated for us. So I'm going to look in my directory and I see I have this foundation subgraph 2. So I'll go ahead and change into that directory. And I'll open this up in my text editor. Okay, so we have our subgraph created, and we have a lot of code that's been already generated for us. But let's kind of go look in the three main parts that make up this subgraph. One is the GraphQL schema, and this is going to be our data model, and we can go ahead and just kind of delete all of that for now. We don't need any of that code. We also have our subgraph.yaml. So if you've ever written any infrastructure as code on something like AWS or any configuration actually in YAML, you probably understand kind of what YAML typically does. It's typically some type of configuration. So it could be like configuration as code. In our case, it's almost like infrastructure as code in the sense that when we deploy this to the network, the indexer reads this file to know what to do with this code base. So the subgraph.yaml, all of the configuration that you're going to need. So we're given, some boilerplate. So I might go ahead and just delete those entities because we're not going to be using those. And we're going to be deleting a lot of these event handlers as well, but let's not worry about that right now. What we want to do, I guess, next is let's go back to our workshop. And I'm going to jump now to the GraphQL schema. This is going to be where we define the entities that we want to store and make queryable. So when we look at this website for Foundation, what might the data model that we want look like? Well, we automatically kind of see these entities like this. You could think of as an entity. This is a token that has a picture and it has a description, has a price, it has all this other metadata around it. So we might say, okay, for each of these images or these pieces of art, we might say this is going to be a token, and then the token has different properties. So for us, we can just go ahead and say, okay, we want a type of token, and then we want to have the different fields on that token be the different metadata associated with that we want to kind of save. And then we also might want to create a relationship between tokens and users, because we might want to be able to click on a user like this and see all of the different tokens that they've created. Or we might want to click on a user and see the tokens that they own. So that's kind of what we're going to also do. We're going to have a user type. User has a relationship between tokens owned and tokens created. So using this data model, which is not all that big, we can go ahead and have a data model for our API that's about 16 lines of code. So the token is going to have an ID that's going to be like a unique identifier. It's also going to have a token ID. The token ID is going to be the ID that is generated by the smart contract. So if someone mints a new token, the contract automatically assigns them that token. The content URI is going to be the URI for the actual image. And then we also have a token IPFS path that is going to be the IPFS address for that token as well. We have a token name, and then we have the created at timestamp that is going to be the block time that the token was created. And then we have the relationship between the creator and the owner. And finally, we have the user, which is pretty basic. All we care about really is the ID. Well, it's not really the only thing we care about. It's the only thing we have to know about a user, because all the user is going to be essentially giving us when they authenticate is their wallet address, and that's going to be their ID. And then we also can now create a relationship between the user tokens that they've purchased and the tokens that they've created. So we can go ahead and save this and go back to our subgraph.yaml. And now we can fill out our entities. So we have a token entity and a user entity. So I can just say token and user. The next thing that we want to do is we might want to go ahead and continue modifying our configuration. So we've done the entities of token and the user. We now need to update our event handlers as well as our address and our start block. So let's go ahead and jump down here, and then we'll do the event handlers in just a moment. So when we deploy this, this subgraph, it's going to go to this smart contract here. It's going to go ahead and find all the transactions that have happened. Actually, it's going to go to the original contract address, which I believe is here. It's going to go ahead and it's going to start looking at all the transactions that have happened for this smart contract. But it doesn't know where to start on the blockchain because, you know, the original transaction that happened, the first transaction that ever happened, it might not realize that it doesn't need to start from there and kind of read everything that's happened ever since then. So if you wanted to do that, you would just deploy it as is, but you instead can say, okay, when this contract was deployed, it was at this block number. And then we want to just start from that block number because we don't really care about any data that was stored before that because our contract was not there before that. So we can define the start block by just setting the block number here. And then instead of going all the way back, it's just going to start at the block from which this contract was deployed or from wherever you set the start block to be. The other thing we want to do is we want to update the contract address to this address here. And that is because when we kind of went to this contract a moment ago and we looked at the actual contract address, we read that this was a proxy contract. And this is very kind of, I would say, a little advanced for most of the rest of the workshop, in the sense that this kind of goes into how you might make an upgradable smart contract. And instead of having the contract that you deploy be the source of truth, you can essentially have it pointing to another contract and then update the location of that contract so that when you make updates, you can kind of be pointing to another contract. That's kind of what this contract is doing. So when we initialized it, we wanted to index the events off of one contract, but when we deploy it, we want to be actually indexing a different contract. So that's why we're updating this address. And then finally, the only two event handlers that we care about are these two. We have token IPFS path updated and transfer. So I'm going to go back to this and I'm going to find those two events, which are going to be these two at the very bottom, token IPFS path updated and transfer. And I'm going to delete all the rest of these. So now we have about 27 lines of code. So let's talk about these event handlers. So I mentioned in the smart contract, we have these events that are emitted. And in a GraphQL API that has subscriptions, you have these subscriptions that are listening to events that are emitted, maybe in a GraphQL API. And then in your client application, you're going to handle that event. So you might listen to that event. And then when that event happens, you might do something locally. Well, we're kind of doing something like that here. We're basically saying when this event is triggered, we want to listen for that and we want to handle that by calling another function. But the function is actually living in our API and our subgraph. So we have two events that we're going to be caring about for our API. One is the transfer event. And this function gets fired, or this event gets emitted when someone creates a new token. And it also gets emitted when someone transfers a token from one party to the other. So when you create a new token, this will be fired. And then when that person moves it to another party, it will be fired. And when that event gets triggered, we then essentially are just calling this handle transfer function that we'll take a look at in just a moment. And then the only other function that we care about is the handle token IPFS path updated function. And that means if someone has a token and they change the IPFS path, we want to be able to handle that update and make that change locally. So where are these two event handlers living? They're going to be living in this src/mapping.ts file. And there's a lot of boilerplate code generated for us here, but we can go ahead and delete that. And this is where we're going to be essentially writing the business logic to handle these two events. But before we do that, we can actually use the Graph CLI to generate some code that will help us out there. So if I go back to the terminal and I just run graph codegen, this will introspect our GraphQL schema and it will generate some code that will be helpful for us. What is that code going to do? Well, there are two things that you're going to be doing in these mappings. When you are thinking about what we're trying to accomplish here, we're kind of like saying, okay, we have this smart contract. We're describing the data that we want indexed, and we're deploying this to a network of nodes. And that network is going to read this subgraph, and it's going to go through and it's going to save the data that we want saved. And then we're going to be able to kind of like query that from our front end. Well, where is this data being saved? Well, it's being saved in the actual node itself. So a node you can think of as kind of like someone running a server, right? But it's kind of like being run on in multiple places. So in this server, we might have a database, and in this database, we want to save information. So one of the things that you're going to be doing here is just saving information to that node. The other thing that you might be doing from this from these functions is calling back to the smart contract, because you might need additional data from the smart contract that isn't coming in from the arguments. So when we emit an event, we might have like some information about what's going on there, but we might not have all the information. So we might need to talk to both the graph node to read and write data, but also to talk to the smart contract itself to read data. So with that being said, that's kind of like just giving an idea of what we're about to do. Let's go ahead and write some of that code. And that's going to be here in the assembly script mappings. So I'm going to jump here and I'm going to go ahead and import the two imports that we need. These two events at the top, the token IPFS path updated event and the transfer event, these are really just types that we can use kind of for type safety. So the CLI generates types for us to use. And the only actual interface that we're going to be interacting with here to make any type of API call is going to be this token contract. And this basically gives us a binding that allows us to speak to the smart contract to read information. So we can say we want to ask the smart contract for information using some like token ID or something like that. So this generated / token is an API for us to talk to the smart contract. And then this generated / schema are APIs that allow us to talk to the graph node. So from the graph node, we might read and write data. And that's kind of what these two APIs are going to allow us to do. So we might say token.save or user.save and so on and so forth, or token.load, so on and so forth, which we're about to do. All right, so the first function we might want to work with is going to be the smaller of the two. So the token URI updated. This is going to take in an event. What we're going to first do is we're going to say we want to load the token from the graph node. And this means like this token already exists. And if it does exist, then we want to continue going. If it does not exist, we just return from this function. So we say token.load. And in this event, we have this params object that has a token ID. So we're essentially getting the token ID from the handle token URI updated event. And if we go here to subgraph.yaml, we see that we have the first argument, which is an integer, and this is going to be the token ID. So that's really the only thing that we care about is the token ID. So if the token does not exist, we return. If it does exist, we then just update the token IPFS path with the event.params.token IPFS path that is coming in through this event. So we get the token ID, we query for that token, we then update the token IPFS path, and then we call token.save. And this is saving that data back to the database. And then we have now updated our token. And then the only other function that we have is the handle transfer function. So go ahead and copy that. And this is the function that I mentioned gets called when a new token is minted. and then also when someone transfers a token to someone else. So let's say they sell the token or they just move it somewhere else. They give it to someone else. So we do something very similar here. We first just load the token using the token ID coming in from the event. And we check if the token does not exist. If the token does not exist, this means that this is a newly minted token. So we need to go ahead and create it. So we call we call new token, passing in the ID. This creates a new token. We then add the creator and the token ID properties. So we have that coming in also from the event. And that's really the only information that we have that we can use it up to this point. We also, though, need more metadata about this token that isn't available in the event. Because if we go to this event, we see that we only have the from address, the to address, and the token ID. But we also want to have other information about the token. We might want the content URI, the token IPFS path, the name, and the created at timestamp. So where does that information come from? Well, that comes from the smart contract itself. So we're now going to bind to the smart contract here. And then we're going to go ahead and start getting information. So we want the content URI, the token IPFS path, and the name of the token. And then the created at timestamp actually comes off of the event.block.timestamp, which is available in every single transaction that happens. So that's a lot, but that we basically just said, okay, if there isn't a token, we want to go ahead and create that. And we're going to now set the owner, and we're going to go ahead and save that to the graph node. And then we'll continue on, and we'll see if there is a user, then we do nothing. If there isn't a user yet, we go ahead and create the user. So that is the handle transfer event. So we have these two events. They're both being defined in our subgraph.yaml, and they are both handling events that are being fired from the smart contract. So I think that's it. So if we go ahead and save that, we should be able to go ahead and test this out. So from there, we've written all the code that we need to make this work. So we can run a build just to test out that our build is working by running graph build. And if this works, we should be able to go ahead and deploy. So the build worked successfully. So I'm going to go back now to the dashboard here. And I'm going to need this access token in just a moment. So I'm going to run graph auth and then this endpoint. And then I need to paste in my, let's see here, the access token. So I'm just going to say graph auth, the endpoint and the token here. And this should go ahead and authenticate me to be able to deploy there. So now I should be able to run just yarn deploy. And this should go ahead and run graph build and then deploy our subgraph. And then what is going to happen is, like, once this is deployed, then the indexing should start happening immediately. So you now automatically see that we have the syncing. It looks like it's already synced, which is pretty quick. So 100% synced, 13 million blocks, 159,000 entities. And that was very quick, actually. Okay. So all this data should now be synced. So what we can now do is start running queries. So I might say I want to get the tokens. And there we go. We see that the data is coming back. We might want to do this a little different, though, because we don't want to get it in that order. We might say order by like ID, and then order direction is going to be like descending. And there we get like the ID of 99.99. And if I go, I'm just going to go ahead and copy this this content URI. paste it there. There you see we have the token information, which is essentially like a JSON object. We also have the token IPFS path. So if I just do ipfs.io/IPFS/that, then we also have that information. And then we have the token image. So if I copy this and I just maybe replace that with that, then we see that we have a video of some sort. And take a look at one more. There we go. We see that coming through. So now we have deployed the API. It's indexed, it's saved all of this data. It's given us an API endpoint, which is this API endpoint. And we can now pull this into our front end application. And we essentially are going to have the ability to build out UIs like this. So using an API like this, you can actually combine multiple contracts. So you don't have to just use a single contract. So there are dozens of different smart contracts for NFT marketplaces. So let's say you had an idea for a more comprehensive front end that you could build across all of these, then you would just build out a smart contract. You would just build out a subgraph. And then instead of having a single data source, you would just have multiple data sources. And you could serve these all up via like a single endpoint. In addition to like using your own subgraph, you can actually explore other people's subgraphs as well. So these are a handful of subgraphs that are some of the more popular ones. And then you can kind of like search down here, all the subgraphs that are available. And you can query those directly from here, or you can use the endpoint and use those as well. So I think that wraps up the main part of the workshop. Here we have a couple of different queries that you can run. Let me try this one actually. I'm not sure if we added that created at timestamp. I think we did. Okay, cool. So this should be like the most recent token that's been created. Nice. So that kind of wraps it up. I guess I'm going to jump back to my slide deck here. If you want to learn more about the graph, I would check out the graph protocol on Twitter. You can check out thegraph.com a little bit more in depth, just go into more of the docs and stuff that we have there. You can also join our Discord to ask questions. And you can also follow me on Twitter, Dabit3, D-A-B-I-T, and the number 3. I'd be happy to answer any questions. And when you're kind of building out an application, you often think of like, what is the stack that I need to kind of get something accomplished? For me, when I was building out traditional applications, it would be something like AWS might have like Cognito for identity, DynamoDB for the database, Lambda for the compute, React for my front end, whatever. So like you have this idea of like, what is the Web 2 stack? Well, it would look something like that. Well, if you want to build something that has that implements and works with some type of smart contracts, like what does the Web 3 stack look like? I'm working on a blog post that dives into that, but you kind of have these different pieces that are a lot different than what we're used to. And I think the graph protocol is a large part of what that stack looks like. And I think that the more that you learn these different things, it doesn't have to be used for everything. Obviously, you can only use blockchain and Web3 for certain use cases. But let's say you learn this along with like a handful of other things, you kind of expand your capabilities. There's definitely a lot of people hiring for this type of stuff now. So I encourage you to dive in and learn more about it. And if you have any questions, feel free to hit me up. And I think that wraps up my presentation. So I'm going to go ahead and stop sharing and see if anyone has any questions or anything like that. And I know that was a lot, especially if you're new to Web3 and new to blockchain. So don't feel bad if it was a little bit maybe over your head on some of that stuff. I'm still learning all this stuff, and I know it's a lot. So. If there are no questions, I might go ahead and jump off. So yeah, thank you for anyone that showed up and hung out today. And I will see you around online. I hope you have a great holiday.